quadratic function is any function of the form f of x equals ax squared plus bx plus c. We studied how to solve quadratic equations in section 1.5, and here we'll talk about some other properties of these functions. To start, we'll talk about the graphs of quadratic functions in general. The graph of any quadratic function is called a parabola. A parabola is in the shape of a U. Okay, and it will open upward or downward depending on the value of a, the value in front of x squared. We call the lowest point or the highest point the vertex of the parabola. And every parabola is symmetric with an axis or line of symmetry going down the middle of the parabola through the vertex. There are two forms of equations for quadratic functions. The first form is called the standard form, and that is when the function is written in the form f of x equals a parentheses x minus h squared plus k. This form is an equation that has had transformations or shifts of the graph x squared. So our first task is to look at how do we graph a function that is in standard form. So example number 1, we have f of x equals x plus 3 squared plus 1. So to graph, what we're going to go through and find for most problems is the vertex, the axis of symmetry, the y-intercept, and possibly the x-intercept. So we'll find those for this example. And then on your homework, you'll be using the quadratic function graphing tool, where you'll be using the vertex and intercepts to graph your function in MyMathLab. Okay, so first off, the form again is a times x minus h squared plus k. So notice you have a minus sign right here. So in our equation, we've got a plus. So how could that minus in the form have changed to a plus? Well, that means that we must have had a negative 3, because x minus is the form, and if we have a plus, that means we must have had a negative 3 for h. So for our vertex, we can find this just by looking at the equation. The vertex must be, for x, negative 3. And for y, it's plus 1. So the vertex is negative 3, 1. That's one of the nice things about the standard form, is that you can always find it just by looking at the equation. Okay, just remember, minus is in the form, so if you have a plus, that means your h must have been negative. Okay, another thing you may be asked for on any problem is the axis of symmetry. Okay, the axis of symmetry, again, is the line that goes straight down through the parabola. That always goes through the vertex. So it's the vertical line, x equals. The x equals is important because we're referring to a vertical line, and equations of vertical lines always start with x equals. And it equals the x-coordinate of the vertex, negative 3. So there's your axis of symmetry. That will cut that parabola in half. Okay, you may also be asked to find the y-intercept. To find the y-intercept, no matter what the function is, we always want to take x and replace it with 0. So our y-intercept will equal 0 plus 3 squared plus 1. Okay, so that's 3 squared, which is 9, plus 1, which is 10. So the y-intercept in ordered pair form is 0, 10. Okay. The last thing you may be asked to find are the x-intercepts. So no matter what the function, to find x-intercepts, we take f of x or y, let it equal 0, and then solve for x. Okay, well, if you have an equation in standard form, it is set up perfectly to use the square root property. So to solve this for x, we'd first want to subtract 1. and get negative 1 equals x plus 3 squared. If x plus 3 squared equals negative 1, that means that square root of negative 1 is equal to x plus 3. Well, the square root of negative 1 is I, and i's do not show up on graphs. So if you're led to an I when solving for the x-intercepts, that means that there are no x-intercepts. So how we would graph this is, in the homework, you're going to select the quadratic graphing tool on your graph. Okay, and you'll start with the vertex. The vertex is negative 3, 1. So you would graph the vertex. The y-intercept is 0, 10. Okay. And you need a third point. On this one, we don't have any x-intercepts to use. So what we need to do on this one is use the symmetry of a parabola. So remember, right down through the vertex is the axis of symmetry. Okay, and so if I take my y-intercept and I see how far away from the axis of symmetry the y-intercept is, if I go the other direction, I should have another point the exact same height as the y-intercept. Okay, so y-intercept is 1, 2, 3 units from the axis of symmetry. So if I go 3 units the other direction, 1, 2, 3, I should have another point the exact same height as my y-intercept. And so now my math lab will automatically draw this parabola for you. Okay, so again, if you're missing a point, count from your y-intercept to the axis of symmetry, go the other direction, and you should have another point the exact same height as the axis of symmetry. Example 2, graph the function f of x equals negative 2 times x minus 3 squared plus 8. So again, start with the vertex. Vertex we can visually see. Remember, the form is x minus h, so this minus sign is part of the equation, and that tells me h is positive 3. So when looking at the vertex, you always want opposite of what you're seeing. If you're seeing a minus 3, that means x is going to be positive 3. Outside, y-coordinate exactly as you see it, plus 8. Axis of symmetry, x equals, the x-coordinate is 3, so x equals 3 is the axis of symmetry. And again, the x equals is important because we are listing the equation of a vertical line. Y-intercept, we always put 0 in for x. So we have negative 2 times 0 minus 3 is negative 3, squared is 9. And so we have negative 18 plus 8 is negative 10. X-intercepts, make y 0, and then solve for x. So we would want to subtract 8. Divide by negative 2. If x minus 3 squared equals 4, then the square root of 4 equals x minus 3. And square root of 4 is 2. So plus and minus 2 equals x minus 3. and split that up into two separate situations. X minus 3 equals 2. X minus 3 equals negative 2. And now solve this for x. Add 3. Add 3. And we get x-intercepts of 5 and 1. So here you have plenty of information to use 3 points to graph the quadratic function in MyMath.